Okay, question 2. First thing is, guys, go to your calculator and type in x is your L1 and y is your L2. Share over my screen for that. Okay, stat, edit, and well, I don't have my data right there easily enough for me, so let me bring it up off to the side here. Okay, sorry about that. Was not prepared to not see my data. All right, so stat edit L1 is 2. Well, sorry. Sorry, guys. Try this one more time. Okay, 2, 4, 6, 8, 10, and 12. L2, 5, 15, 26, 23, 11, and 3. Okay, stat plot. To get our scatter plot, make sure plot 1 is on. It's off by hitting enter, and hitting enter again. Off goes to on. It's ready to graph now. It shows 1 point, but I need to see them all. So zoom, option 9 to zoom stat. Reconfigures it. And wow, that does not appear to be linear as we look at this data. So on this one here, I would say we would, for part B, describe the association shown in the scatter plot. It does not appear to have a linear or does not have to appear to have a linear association there. If anything, it appears to be, say, quadratic. But then we're going to go ahead and calculate the correlation coefficient and the least squares regression line. We can still make one. It just may not be great. So to do that, we're going to have to turn on our correlation coefficient. Second, 0. Oh, sorry, I hit the wrong button. Try this again. Second, 0 to turn the catalog on. And go down to diagnostic on. Gotta go down to these, turn on diagnostic on. Okay, whoops, diagnostic on, hit twice. Now it's on. Stat, calculate, option 4 is where we've been living. Run it all. And right here, that correlation coefficient makes sense from what I saw in the scatter plot, because the scatter plot sure as heck did not look linear. So in this case, it is showing it's very close to 0, which would make sense then. Okay, so we can make it, okay, a regression line from there for parts C and D, which we will do now. So let me go back to my notes, or back to the warm-up. Sorry, wrap up. And the scatter plot we had gotten was at 2, 5, 4, 15, 6, 26, 8, 23, 10, 11, 12, 3. And describe the association shown in the scat. Appears to be quadratic and not linear. Correlation coefficient, we looked at our calculator. We got a negative 0.14, which is very close to 0. So this implies not a strong linear association. And we can, again, determine the equation, y equals mx plus b. It's just not going to do a very good job of modeling our data. Let's go with 1 decimal, negative 0.4 x plus 16. I think I'm going to go with just 16 here, because I doubt they use that on the next page. Now that we have that, we're going to go ahead and still calculate our predicted value of negative 0.4x plus 16. I want to check something here real quick before we go on. Negative 0.4 times 2 plus 16. 5 minus 15. 5, so it looks like they did do, just trying to see how they rounded. Okay, so they did go with 1 decimal to 16.3. Okay, so let's use that equation to help us calculate the predicted values like we've been doing. Where they get the 15.5 from is negative 0.4 times the x plus 16.3. That gives them 15.5. So we want to repeat that to calculate the rest of the predicteds. Okay, so go to your calculator. Negative 0.4 times 4 plus 16.3. That gives me 14.7. And I keep repeating this process. Negative 0.4 times 6 plus 16.3, 13.9. Now they did that for us already. That's where they're getting 13.1 here from. Negative 0.4 times 8 plus 16.3, that is 13.1. And then for the next one, negative 0.4 times 10 plus 16.3, we get 12.3. And then for the last one, 12. So negative 0.4 times 12 plus 16.3 gives me 11.5. Now to calculate the residual values, so I can do my residual plot, I'm going to be taking the observed, which is the y value, minus the predicted value. That's how I'm getting negative 10.10, negative 10.5. So y, the observed, minus the predicted. That is 0.3. And then 26 minus 13.9. That's how I'm getting 12.1. 23 minus 13.1. So 23 minus 13.1 is 9.9. 11 minus 12.3 is negative 1.3. And then lastly, I'm doing the 3 minus 11.5. So for the last one, I get negative 8.5. Now I'm going to go and make the plot to confirm that probably we do not have a linear data set. So I'm going to plot my x's with then the residual values I just calculated. So what I mean by that is 2 and negative 10.5, 4 and 0.3. So 2 and negative 10.5, 4 and 0.3, 6 and 12.1, 8 and 9.9, 10 and negative 1.3, 12, negative 8.5. That's what I'm plotting. So that's what I'm going to write over here on the y's, is going to represent my residuals. Okay? And the x's are still going to stay the x's. Now looking at my x's, my scale, I'm going to go by 2's. And for my y's, I'm going from all the way up to 10.5. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I might make those go by 2's as well. Okay, so going by 2's, negative 2, negative 4, 2, 4, 6, 8, 10, 12, 14, 16. All right, let's go do this. 2 comma negative 10.5. So 2 comma negative 10.5. 4 comma 0.3, so very close. 6 comma 12.1. 8 comma 9.9, 8 comma 9.9, 10 comma negative 1.3, 10 comma negative, we just say 1.3, and 12 comma negative 8.5. Okay. So there's my residual plot. What I'd see then is that U-shaped graph, that pattern is there. So the interpretation is saying there is a pattern, there is a curved pattern, which implies a non-linear relationship. Okay. So with that in mind, based on the scatter plot information, the correlation coefficient information, the residual plot information, does the data appear to be linear? And no, for a variety of reasons, but no, because the residual plot indicates that a linear model may not be a good fit for the data because there is a pattern. So because there's a pattern, we're going to say that is probably not a linear relationship. All right, I'm going to pause that there, and then the other ones we will do in class tomorrow.